company insures homes in 3 cities, J, K, and L. Since sufficient distance separates the cities, it is reasonable to assume that the losses occurring in the cities are independent. The moment generating function for the loss distributions of the cities are given. Let X represent the combined losses from the 3 cities. Calculate the expected value of the X to the third. Okay, so the first thing that you want to do, you want to take a look at these moment generating functions. Each is represented for the respective city. Okay, so the J here, you can tell this is a random variable, K is a random variable, L is a random variable, right? So X represents the combined losses, right? So by nature, X will be the sum of all 3 random variables, J, K, and L. Okay, now we need to find the moment generating function of X in order to find the third derivative, right? Because the expected value of the X to the third of the tripled random variable is going to be the third derivative of the moment generating function of X at the point t is equal to 0, right? So what we need to find is the third derivative of the moment generating function of X at the point t is equal to 0. Okay, but before we do that, we have to find the third derivative. But to find the third derivative, you need to find the moment generating function of X. To do that, you have to understand how to use these 3 when you find the moment generating function of X. Notice that the moment generating function of X is going to be the product of all of these 3. And why is that? It's because each loss occurring in the cities are independent, right? So losses occurring in this city J are independent of the losses occurring in city K and independent of the losses occurring in city L, right? So for this reason, we can multiply these moment generating functions together. So moment generating function of J times the moment generating function of K times the moment generating function of L. Okay, so by nature what it means is that we're gonna multiply these guys. So as you can see, the bases are 1 minus 2t in each case, so we can keep it there, and then simply add the respective powers, right? Because the bases are the same, right? So it's going to be negative 3 minus 2.5 minus 4.5, right? Which is going to give you negative 10, right? So that's going to be the ultimate power. So now this is the moment generating function of X. Excellent. So now that we found it, we need to find the third derivative and then find the value at the t is equal to 0 to find the expected value of X to the third. Right, so let's do that. Let's take the derivative. The first derivative, and we assume it's X random variable. We don't have to write it, but if you want, you can. But it's going to be the same thing, right? We assume that it's talking about the moment generating function of X. Okay, so what is going to be the first derivative? The negative 10 comes down, decreases by a power by 1, right? And then multiplies by the derivative of the inside, right? So that's going to be what? That's going to be 20, 1 minus 2t, negative 11. Okay. The second derivative now is going to be what? It's going to be the negative 11 multiplies the 20, so minus 220, right? And then 1 minus 2t decreases by 1, and then the derivative of the inside, right? So that's going to be 440, right? 440, 1 minus 2t to the negative 12. Excellent. So now the third derivative, the negative 12 multiplies the 440, right? So that's going to be minus 5,280. Then 1 minus 2t, the power decreases by 1, and then the inside derivative multiplies. So that's equal to 10,560 multiplied by 1 minus 2t to the negative 13 power. So now you evaluate this at t is equal to 0, and then bingo, you found your expected value of the tripled random variable, right? So this at t is equal to 0 is going to be what? So this becomes 1, right? Because 1 minus 0 essentially is 0, right? So the answer is just simply 10,560, right? So that is equal to the expected value of the tripled random variable. Okay, so this result is, and you're going to find this answer choice in the multiple choices provided on the exam P. Okay, so thanks for watching. Hope this was fun. See you in the next video.